Saturn has some strange periodic signatures in its magnetosphere that scientists have been struggling for years to explain. Using data from NASA's Cassini mission, scientists have come up with one possible explanation. This was accomplished using a computer simulation that proposes swirling wind in the upper atmosphere at high southern latitudes. What's unusual is that phenomena in the upper atmosphere could somehow be a source for odd magnetic behavior far above the atmosphere. In this animation, the researchers have incorporated a wind vortex, shown here as orange contours, into an existing model of Saturn's magnetosphere. Electric currents aligned with the magnetic field are created by the flow in the ionosphere. Stronger current density is shown in blue, weaker current density is shown in white. As the vortex rotates, we see the color of the current density cycle from stronger to weaker and back again. The modeling work shows this change in current strength takes place as Saturn rotates about its pole. Let's now look at how the cycling of the so-called field-aligned currents impacts the large-scale behavior of Saturn's magnetosphere. The blue and white region shows the magnetospheric boundary as the solar wind, represented here by green arrows, pushes on Saturn's magnetosphere. Small blue arrows within the magnetospheric boundary show how the planet's magnetic field deviates from symmetry about the rotation axis due to the field-aligned currents. The magnetosphere breathes in and out as Saturn's rotating magnetic field pushes against the magnetosphere boundary. When the field is stronger, the magnetosphere breathes out. When the field is weaker, the magnetosphere breathes in. Within the yellow circle, the field strength remains essentially unchanged, though the fluctuations rotate. The researchers have studied other aspects of this periodic behavior, as is shown in this next cross-section view of the magnetosphere. In addition to the respiratory behavior of the magnetosphere, you can see Saturn's magnetotail, the windsock region of the magnetosphere extending away from the Sun, slowly flapping towards the north and back to Saturn's equatorial plane. The Sun and impinging solar wind is to the left, Saturn's north pole at the top. The black lines with arrows show the direction of the magnetic field. A thin sheet of electric current is seen as a long, green-shaded object extending to the right. This view shows how plasma density contours, color-coded from densest, red and white, to least dense, blue, also pulse. This model is one proposed solution to a long-standing magnetic puzzle, and Cassini scientists will be watching to see how it holds up to continued observations of Saturn's magnetic field.